Hey you guys, welcome to one more Hui Raptor video. Today we have a different type of machine to show you, and it's different because this time is not a 3D printer. It's a laser engraver from TwoTrees. So let's start by checking what's inside the box. The first thing we see is a bit of cardboard. This will be used to engrave our first tests. Next, we have the assembly manual, memory card, and memory card adapter. Lots of screws and a few belts. The power cord and some safety glasses. When working with lasers, protecting your eyes should be your main concern, but we will discuss this in detail later on, so make sure you stay until the end of the video. Next, we have the power brick. This one has an output of 12 volts and 10 amps. Some cables, and the main board. The main board is equipped with an Arduino Nano, a couple of drivers, and also the on and off switch. One of these drivers will drive the two Y-axis motors and the other will drive the X-axis motor. Some Allen keys and a wrench, wheels, a long USB cable, and the laser module. This one has an output power of 2500 milliwatts and 450 nanometers wavelength. Brackets, pulleys, and eccentric nuts. Spacers, lock nuts, T-nuts and flat nuts, black corner brackets, acrylic plates with almost 6 mm thickness, plastic standoffs, a couple of clear acrylic plates, 3 small stepper motors, and finally 5 V-slot 20 by 20 metal profiles. 4 of them are 450 mm long and the 5th one is 490 mm long. Okay, unboxing done. Let's start the assembly. Inside the package, we find these two papers. One has the list of all the parts, and the other is a very simple assembly instruction guide. And the first step is to assemble the bottom structure. So, let's start gathering some T-nuts, M5x8 screws, and corner brackets. Place the screws and T-nuts on the brackets like this. Next, grab the 4 450 mm long profiles and check which ones have the threads and which ones don't. Place the ones with the threads at the sides and the other ones at the front and back. The Allen key that is included is small and with a flat tip. We recommend using a long one with the round tip. This one will make the job much easier. Now attach the brackets to the corner and tighten the screws. At the end, check the squareness. Next, get 4 flat nuts. These nuts have orientation. If you insert them with the thread facing up, it will be easier to slide the belt under them. But if you insert the thread facing down, it will be harder to slide the belt, but the belt will be better secured. Slide a couple of them on each side profile. Now, get the feet plates. Before installing any of the acrylic plates, take the protection sheet off. On one side, you need to install the screw and T-nut. The other, you just insert the screw and tighten it to the threaded metal profile. Do the same for all 4 feet. Next, get both left and right Y-axis carriage plates. For each, you will need a couple of spacers, 1 eccentric nut, 3 M5x30 screws, 3 lock nuts, 3 wheels, 1 pulley, 1 stepper motor, and 4 M3x10 screws. At this point, check carefully each wheel. We found that the bearings on some wheels had rust on them, so we had to clean and then lubricate them with oil before installing them. Now, take the plate and insert the screw, then the spacer, the wheel, and finally the lock nut. Do the same for the other side hole. For the third hole, insert the screw, then the eccentric nut, and for this, make sure you have the correct orientation. Then, the wheel and finally the lock nut. Tighten both fixed wheels and leave the adjustable wheel loose for now. Next, place the motor and secure it with 4 M3 screws. Rotate the motor shaft so you can locate the flat side and insert the pulley. One of the set screws must be tightened against that flat side. Make sure you adjust the height of the pulley so that it matches with the wheels. Then tighten both set screws. Repeat all of this for the other plate, but mirrored. Next, get the B1 X-axis carriage plate. Get an M5 by 30 screw, add the wheel and one eccentric nut. Then insert it on the plate. Add the lock nut and tighten it. Place the stepper motor and secure it with 4 M3 screws. In our case, we couldn't tighten one of the screws because one of the holes on the acrylic plate was not aligned with the motor, so we just used 3 screws. As before, install the pulley, adjust the height, and tighten both set screws, making sure that one of them is tightened against the flat side of the motor shaft. Next, get the B2 plate and the laser module. On the laser module, locate the side with the threaded holes and secure the plate on that side with the M3 screws. Now, get the M5 by 40 screws and insert them on the B1 plate. Add a spacer, then the wheel, and then a second spacer. Do the same for the other side. Then get the B2 plate and attach the B1 plate. Get a couple of lock nuts and tighten them. Next, get the longer profile and insert a couple of flat nuts. Use one of the M5 by 10 screws on the top hole and tighten it to the metal profile. Get the black bracket and place one M5 by 8 screw and T-nut to it. Place the bracket on the corner between the plate and the profile. Then use an M5 by 12 screw and lock nut and tighten them. Slide in the X carriage and tighten the other Y carriage on the other side. And this is how it looks like after assembled. Now place the moving axis on the base structure, but for this you need to remove the adjustable wheel on the Y carriages. Place the moving axis and then tighten the adjustable wheels. Now it's time to adjust the grip of all the wheels by turning the eccentric nuts. If the wheels spin freely, turn the eccentric nuts until they stop spinning. Don't turn the eccentric nuts too far, because you will end up with too much grip and the wheels will deform. Next, get the belts. Slide the flat nuts to the edges of the profiles. Pass the belt under the wheels and over the pulley. Then, slide the belt under the flat nut. Use the screw to secure the belt on that side. On the other side, pull the belt and cut the excess at the edge of the profile. Slide the belt under the flat nut and tighten the screw to secure the belt. Now, check the movement by manually move the axis and also check the alignment of the pulley with the belt. Repeat the same procedure for the other Y-axis belt and also for the X-axis. Now, turn the engraver around. Take the clear plate and add screws and T-nuts. And also the small plastic standoffs with M3 nuts. Install the plate at the back side metal profile. Attach the board and secure it with the longer plastic standoffs. Next, get the cables. Start by connecting both Y-axis motor cables to the board. Next, connect the left Y-axis cable to the left side motor and the right Y-axis cable to the right side motor. The cable with the extra connector goes to the driver from the right. This will be the X-axis motor cable. The extra connector will power the laser and will be connected here. Connect the X cable to the X motor. And then the laser. In our case, we decided to install the motor with the connector facing down. You can install it facing up, but we prefer this way because we wanted to add a cable tie mount, and this way the cable will stay up and away from the moving axis. We also added one cable tie mount on each Y-axis motor, and also on the back side profile to keep all the cables organized and also away from the moving parts. To finish the assembly, we still need to place the cover panel on the board. But this panel will block the access to the on and off switch, so for that reason we decided not to install it. Now all we need to do is connect the power cable. Then turn on the switch and connect the USB cable from the engraver to the computer. For the first tests, we can use the cardboard that came with the engraver. Inside the memory card, you will find the drivers and software needed to work with this engraver. When opening the software, it will enter the first tab. There are 4 tabs with options. In the first one, we can connect and disconnect the engraver, move the axis around, load and tweak the images that we want to engrave, test the print area. We can define our working area and define the burning time. On the second tab, we can load NC and DXF files. On the third one, we can engrave text. And on the fourth tab, we can check all the machine settings such as speed values, acceleration values, step per millimeter, axis direction, etc. Your 00 coordinate will be at this corner by default. You can easily test that by moving the axis on the first tab. If you notice your engravings are getting mirrored, you need to reverse the axis direction here to fix the axis orientation. Now, before turning on the laser, let's talk a little bit about safety. As you all know, lasers, and especially these ones that have more power, can easily hurt your eyes. And it's not only when pointing the beam directly to the eyes. Looking to the laser dot is also not safe. Reflections are also dangerous, and these can easily be made with mirrors, glass, or shiny surfaces. The engraver includes safety glasses, but we can't honestly say that these are designed and safe to be used. There are no documents or specs included in the package, and there is nothing written on the glasses that state for what kind of laser they are designed for. There is also no information about the optic density value of the lenses. On the glasses frame arms, we can only find a couple of markings. One is an European standard and the other is American, but none of them is related with lasers. So, that being said, we cannot say for sure that these glasses work and that you are indeed protected. If you want to be 100% safe, you should buy certified glasses from a trusted seller and with the ideal optic density values for these 450 nanometer lasers. But this, however, only covers half of the problem. Even when using good quality safety glasses, only you are protected from the laser light. Any other person or animal that enters the room will be exposed. One solution would be to build an enclosure for the engraver. And you can add a webcam inside the enclosure to monitor the machine from the outside. Or lock the room where the engraver is in and have a Wi-Fi camera directed to the machine. One other concern is related with the fumes. Because the laser will burn material, it will release fumes and therefore it is recommended to have the engraver in a well-ventilated area. Okay, so back to our engraver. As you notice, there are no end stops on this machine, so the engraver will never know where the axis will be. So the position where you leave the axis will be the 0 coordinate. Before starting our first test, we will need to adjust the focus of the beam. In the software, turn the laser on with the weak option. Then you need to rotate the laser lenses until you get the smallest and sharpest dot. Next, load the image and click on Test Size. This will move the axis around the area where the drawing will be made. This is good to check if the material is big enough and if it's aligned. And now it's ready to engrave. And these are the tests we made. Some images ended up with pixels too big. That is related with the software itself and not the hardware because the engraver can produce very small dots and thin lines. Although the software can easily help us set up and work with the machine in terms of mechanics, the image's interface, on the other hand, could be a little bit better. And that's it, you guys. If you liked the video, leave us a like. Don't forget to subscribe and keep following us here on YouTube, Facebook, Instagram, and Twitter. If you wish to help the channel, you can with our affiliate links, Patreon, or PayPal. We will see you guys next time. Bye!